Hey there everyone, Ramesh here, back again with another video. In this video tutorial, we'll learn how to build the real-time REST APIs for banking application using Spring Boot. Well, basically we're going to build the real-time REST APIs for banking application using Java, Spring Boot, Spring Data JPA and MySQL database. We'll basically build the REST APIs for features like add account, get all accounts, transfer amount, deposit amount, remove amount and more. So we'll also learn how to handle the specific kind global exceptions and return the error response back to the client. Well, you will learn how to handle the specific kind global exceptions in a real-time Spring Boot applications. Next, you will learn how to use Java records as a DTO to transfer the data between client and server. So basically, we are going to utilize the latest Java version features like Java records to create a DTO and transfer the data between client and server. And we are going to use IntelliJ IDEA to develop this project, and we'll use Maven as a build tool, and we are going to use the latest version of Java, Spring Boot, Spring Data JPA and MySQL database. Alright, so without further ado, let us go ahead and let's create a Spring Boot project using Spring Initializer and import that project in IntelliJ IDEA. Just let us jump into the browser. So I'm in a Chrome browser and open the new tab over here and just type start.spring.io. This will bring up Spring Initializer. And here select the project Maven and choose the language Java, and let us keep the stable version of Spring Boot as of now, that is 3.2.1. so this is the latest and stable version of Spring Boot as of now. Next, go to the project metadata over here, and here let us give group as net.java guides, and let's give artifact as banking app. Next, project name is same as artifact, that is banking app. Next, description, let us give the description something like demo project for Spring Boot banking app. Next, let us give package name as net.javaguides.banking. Next, let us keep packaging as a jar, and let's keep Java version 17. Next, go to the dependency section over here, and here just search for web, and let us select this Spring Web Starter dependency. Well, we use this dependency to build the RESTful APIs, and this dependency internally provides Apache Tomcat Server as a default embedded container. So let us select this dependency. Next, let us type Spring Data JPA. Well, we are going to build the JPA repositories using Spring Data JPA. Well, this Spring Data JPA dependency internally provides latest version of Hibernate. Okay, so let us select Spring Data JPA over here. Next, type MySQL. So we are going to use MySQL JDBC driver to connect our Spring Boot application with the MySQL database. Next, let us select the Lombok dependency. Well, we are going to use Lombok dependency to reduce the boilerplate code such as getter setter methods, constructors, toString equals and hashcode methods. Okay, so let us select Lombok dependency over here. Alright, so as of now, these dependencies are enough for our Spring Boot application. Next, go ahead and click on generate button over here. So before that, you can also explore the Spring Boot application using explore option over here. So just click on explore, and here go to the pom.xml file, and you can see the Spring Boot version, Java version and the dependencies as well. Okay, perfect. Next, click on close button and go ahead and click on this generate button to generate the Spring Boot application as a zip file. Okay, next go ahead and open this zip file in a folder. Perfect. Next, let us unzip this zip file. Alright, next let us open the IntelliJ IDEA. So here I have opened IntelliJ IDEA. Next, click on open option over here to open the existing project. In my case, the project is downloaded in a downloads folder. So let me go into the downloads folder over here. And next, let me select the project. Let me click on open. Now we have successfully imported the Spring Boot application in IntelliJ IDEA. Next, let us go ahead and let us start developing this Spring Boot application. Next step is we will configure the MySQL database in our Spring Boot application so that our Spring Boot application can able to connect to the MySQL database. So go to the src folder and go to main folder, go to resources, go to application.properties file. So here inside application.properties file, we want to configure the MySQL database details. Okay, so before configuring MySQL database details in the application.properties file, let us first create the database in a MySQL server. So in our case, we want to use MySQL Workbench to interact with the MySQL server. So here, let me quickly create the new database. So here, let us write the SQL statement, create database followed by the database name. So let us give database name as banking app. Next, let us select this, click on execute, and next refresh schemas. And here you can see banking app database is successfully created. Next, we can make this schema or database as a default so that we can only focus on this database. Next, let's go back to IntelliJ IDEA over here and go to application.properties file, and here let us configure the MySQL database properties. So just type spring.datasource.url equal to JDBC and then MySQL and then localhost and then port 3306 and then followed by the database name banking_app. So this is the JDBC URL that our Spring Boot application will use to connect with the MySQL database. And here we are using localhost because our MySQL server is running in a local machine. That's why the host name is localhost, and this is the default port for a MySQL server, and this is the database name. Next, let us configure the MySQL database username and password. So here spring.datasource.username. In my case, the username is root. Next, let us configure the password, spring.datasource.password. Well, in my case, this is the password, but make sure that whatever the database username and password that you have given while installing the MySQL database, that you have to provide over here. Next, let us tell Hibernate to automatically create the tables using JPA entities. For that, let's configure the property spring.jpa.hibernate.dtl-auto equal to update. Alright, so this property basically ensures that the Hibernate should create the database tables automatically based on the JPA entities that we will create in the Spring Boot application. Next, we no need to add Hibernate Dilate for a MySQL database because Spring Boot 3 internally uses Hibernate 6, and Hibernate 6 will automatically configure the Hibernate Dilate for a database based on the JDBC driver dependency that we add in the Spring Boot application. In our case, we have added MySQL JDBC driver, so Hibernate 6 will automatically configure the Hibernate Dilate for a MySQL database. Okay, perfect. Next, let us run the Spring Boot application so that we can make sure that our Spring Boot application can able to connect to this banking app database. So go to our main entry point class over here, and from here let us run the Spring Boot application, and here click on enable button to enable the Lombok annotations. And notice here there are no errors in a console logs. It means our Spring Boot application is successfully connected with the MySQL database. Next step is we will create a JPA entity. So before that, let's quickly create the packaging structure for our Spring Boot application. So right click on the base package, new, and then choose package. Let's give name as entity. Next, let's create one more package. Right click, new, and then choose package. Let's give package name as controller. Next, right click, new, and then choose package. Let's give package name as service. Next, let's create one more package. Let's call it as repository. Perfect. Next, go to entity package, right click on it, new, and then choose Java class. Let's give class name as account. Next, let us define the fields for this account class. Private long ID, and then private string. Let's give name as account holder name, and then private double balance. Well, to keep it simple, let us have these three fields for our account class. Next, let us make this class as a JPA entity by using JPA annotations. So let us annotate this class with add entity annotation to make this class as a JPA entity. Next, let us configure the table details by using add table annotation. So here let's use name attribute to give a name to the table. Let us say accounts. Perfect. Next, let us use Lombok annotations to automatically create a getter setter methods for this account class. So here let us use add getter Lombok annotation, and next let us use add setter Lombok annotation. Next, let us also use the constructor related annotations. For example, no argument constructor and all argument constructor annotation. Next, let us use few more JPA annotations over here. So go to the ID field and let us annotate this ID field with add ID annotation to make this ID field as a primary key in a database. Next, let us use add generated value annotation to configure primary key generation strategy. So this annotation has a strategy attribute, and let us give the generation type as an identity. So this will basically automatically increment the primary key. Next, here let us use add column annotation to configure the column name for this field. So here let us use name attribute and let's give column name as account underscore holder underscore name. Okay, perfect. Now we have created account JPA entity. Next, let us run this Spring Boot application and let us see whether the Hibernate will automatically create a table for this account JPA entity or not. Okay, so go to main entity point class over here. From here, let us run the Spring Boot application. And notice here there are no errors in the console. Let's go to database and go to banking app database, refresh the schemas, go to tables, and there we go. Accounts table is created, and the columns like ID, account holder name, and balance. It means the table is successfully created and the columns are also looks good. Okay, so let's go back to IntelliJ IDEA. Next step is let us create Spring Data JPA repository for this account entity. Okay, so go to a repository package, right click on it, new, and then choose Java class, choose interface, and here let us give the interface name as account repository. Perfect. Next, let us extend this interface from JPA repository interface. And notice here JPA repository interface is a generic, so we have to pass two parameters. First is the entity name, in our case account. Second is the type of the primary key, in our case long. Okay, so if you go to account JPA entity, so we have given the long type to this ID field, right? So this long we are passing as a second parameter to this JPA repository interface. Okay, great. Well, once we create an account repository interface that extends JPA repository interface, then this account repository will get a CRUD database methods to perform CRUD database operations on this account JPA entity. Alright, perfect. Next step is create add account REST API. So before creating the REST API, let us first create the service layer. Well, the controller layer depends on service layer. So let us first create add account method in a service layer, and then we'll create the REST API, and that REST API will internally call the service method. So here go to service package, right click on it, new, and then choose Java class. And let us select interface, and let us give interface name as account service. Okay, next let us define the method over here. So let us say account and then create account, and let us pass account. Well, we can also use a DTO to transfer the data between client and server. Okay, so what we will do, we'll use the DTO. So let's create a new package for it, and let's give package name as DTO, and here let us create a class and let us give class name as account DTO, and here let us type the field private long id, and then private string account holder name, and then private string, let us go double, and then balance. Alright, and here let us use @data lambda connotation to automatically generate constructors, getter, setter methods. Next, let's go back to account service interface, and here instead of account JPA entity, let us use account DTO. So here also let us pass account DTO. Okay, perfect, and let's view the name as account DTO, and let's remove this unused import. Okay, perfect. Next, go to service package and let's create one new package, and let's call it as IMPL. IMPL stands for implementation, so all the implementation classes we keep under this IMPL package. So right click on this package, new, and then choose Java class. Let's give class name as account service IMPL. So this is the naming convention. Next, this class implements account service interface and implement its methods. So here just mouse on this class, click on this implement methods, select the method that you want to implement, click on OK. Perfect. Next, let us annotate this class with @service annotation to automatically create a Spring Bean for this class. Next, let us inject the dependency. So here let us first declare the field private account repository. Next, let us use a constructor based dependency injection to inject this account repository dependency. So here right click and then generate, and then constructor, and select the dependency, click on OK. Alright, next here we can annotate this constructor with @auto annotation to automatically inject the dependency, but Spring 4.3 onwards we can ignore this @auto annotation, because whenever Spring will find the single constructor in a Spring Bean, then Spring will automatically inject the dependency. Okay, perfect. Next, go to create account method over here, and within this method we need to convert account DTO into account JPA entity, and then we'll save that account JPA entity into a database. So this is the conversion logic, right? So let us create one mapper class, and let us write the common logic, like we can convert a DTO into JPA entity and JPA entity into DTO. So here go to DTO package, or else let's create one more package and let's call it as mapper. Next, within a mapper package, let's create a new class. Let's call it as account mapper. So within account mapper class, let's create static method public static, and let us give the return type account, and let us give method name as map to account, and let us pass account DTO as a parameter. Perfect. Next, let us convert this account DTO into account. So here let us create the object account, and then account equal to new account. Next, let us pass the details to the constructor account DTO.getID, and then account DTO.get account holder name, and then account DTO.get balance, and then finally I return the account object. Now we have converted account DTO into account JPA entity. Similarly, let us write one more static method to convert account JPA entity into account DTO. So here just type public and then static, and then return type as account DTO. Let's give method name as map to account DTO, and let us pass account JPA entity. Perfect. Next, let us create account DTO object over here. Alright, and let us pass values to the constructor like account dot get ID, and then account dot get account holder name, and then account dot get balance, and then finally return this account DTO. Well, let us see what is the compilation error over here. it says the parameterized constructor is not available in the account DTO. So go to account DTO over here. So this at data annotation don't provide the constructor. So here let us use at argument constructor annotation. Okay, let's go back to mapper class, and there we go. Alright, now we have created a mapper class to map DTO into entity and vice versa. Next, let us use this account mapper class in a service classes. So go to account service impl class over here and go to create account method, and here let's create an object of account and then account, and then let us call account mapper over here, account mapper, and then it has map to account method and then pass account DTO. Next, let us call account repository over here, and then it has a save method. So let us call save method to save the account JPA entity, and then pass account JPA entity object to this save method. So this save method basically return the saved entity. So here let us introduce a local variable of type account, and let's give variable name as saved account. Okay, perfect. And if you look at the create account method return type account DTO. So let us convert saved account into account DTO. So here let us remove this null and then call account mapper and then map to account DTO and then pass saved account. Okay, perfect. Now we have created a create account method. It will call the account repository to save the account into the database. Next, let us create the REST API, and then that REST API will internally call this method. So go to controller package over here, right click on it, new, and then choose Java class. Let us give class name as account controller. Let us annotate this account controller class with @REST controller annotation. So this @REST controller annotation will make this class as a Spring MVC REST controller class. Next, let us annotate this class with @request mapping annotation, and let us pass the base URL over here. Let us say /API/accounts. Okay, so this is basically a base URL for all the REST APIs that we are going to define within this account controller class. Okay, great. Next, let us inject the dependency. For that, let us first define the field, that is private account service. Next, let us use a constructor based dependency injection to inject this account service dependency. So here right click, generate, and then constructor, and then click on OK. Now we have injected account service using constructor based dependency injection, and here again we don't have to use @word annotation because this class has only one constructor, so Spring will automatically inject the dependency. Next, here let's create a add account REST API. Well, creating a REST API using Spring Boot is very simple. First we need to create a method, and then we'll make that method as a REST API by using Spring annotation. Okay, alright, so just type public, and then let us use response entity as a return type, and this is generic, so we can pass account DTO as a type. Let's give method name as add account, and then pass account DTO as a parameter to this method. Alright, perfect. Next, let us have a return statement over here. Return new response entity, and then call account service dot create account, and then pass account DTO. Next, let us pass the HTTP status, that is created. HTTP status created. Perfect. Now we have created add account method. It will call account service dot create account method, and this create account method basically return the saved account. So this is the first argument. Second argument is HTTP status. Okay, perfect. Next, let us make this method as a REST API by using Spring annotation. So in this case, this method have to handle the HTTP post request. For that, let us use @post mapping annotation. Next, here let us use one more annotation, that is request body annotation. So this add request body annotation will map the request body to this Java object. So request body basically contains JSON. So this add request body will automatically convert that JSON into this Java object. Okay, perfect. Next, let us go ahead and let us run our Spring Boot application and let us test this add account REST API. So from here, I am going to stop the running application first and I am going to run the application again. And notice here our Spring Boot application is up and running in a embedded Tomcat server on port 8080. Next, let us open the Postman REST client. And here let's create one new request. And here let us choose HTTP post method and just type the request URL HTTP localhost 8080/API/accounts. Okay, so if you go to project again and if you go to account controller, the URL is /API/accounts. So this is the URL we are using over here, /API/accounts. Okay, next go to body and then select raw, select content type as a JSON, and here we need to pass the JSON in the request body. So let us quickly create the JSON object. So if you go to project again and if you go to account DTO, so this account DTO has field account holder name and balance. So these fields we have to use in a JSON. So let me copy this field name and let me paste it over here. And then let's give holder name, in my case Ramesh. Next, balance, let us say 10,000. Okay, next go ahead and click on send button and there we go. We got the response from the server, and if you look at the ID here 1, so this ID we are getting from the database, and look at the status 201 created. Let us verify in the database. So go to MySQL Workbench, go to accounts table, select rows, and you can see the account is successfully stored in a accounts table. Okay, perfect. Now we have successfully built add account REST API. Now we have developed a get account REST API. Next, let us build deposit REST API. Well, basically we are going to develop the REST API that will deposit amount into a account holder name. For example, here the account holder is Ramesh. He has a balance 10,000. Next, we are going to deposit some amount into this Ramesh account holder. Alright, so basically we are going to add some amount to the existing balance. Okay, it's pretty simple. So let us go to IntelliJ IDEA over here and let us first develop the service layer. So go to account service interface and here let's give account DTO as a return type. Let's give method name as deposit and let's pass first parameter as ID. Next, let us pass second parameter as a amount that we want to deposit into account. Now we have defined deposit method in account service interface. Next, let us provide the implementation for this deposit method in a account service sample class. So let us jump into account service sample class. Mouse over on this class, click on implement methods over here and then click on OK. Next, let us implement this deposit method. Well, within a deposit method, first we will check whether the account with a given ID exists in a database or not. If the account with a given ID is not exist in database, then we will throw the runtime exception, right? So here we have already written a piece of code. So let me copy this piece of code and let me paste in a deposit method. Now we got the account for this particular account ID. Next, let us call its get balance method and then add this amount to existing balance. Okay, next here let us introduce a local variable double and let's call it as total equal to. Perfect. Next, let us call account and then let's call it set balance method and then pass total. Okay, perfect. Next, we need to save this object into a database. For that, let us call account repository and then call save method and then pass account object. Perfect. Next, this save method returns saved account object. So here let us introduce a local variable account and then saved account. Next, this deposit method returns account DTO. So let us convert this account JPA entity into account DTO. So here let us remove this null and then call account mapper. It has map to account DTO and then pass saved account. Okay, perfect. Now we have implemented deposit method. It will deposit an amount into an account, and the logic is pretty simple. We will get the existing balance from the account and we'll add the amount to the balance, and then we'll get the total amount, and then we'll add that total amount as a balance to the account, and then we'll save that account into a database. Okay, it's pretty simple. Next, let us build the deposit REST API that will internally call this method. So go to account controller and here deposit REST API. Alright, so here let's type public, let's give return type as a response entity, and here let's give the type as account DTO, and let's give method name as deposit, and then let us pass two parameters to this method, long ID, and then second parameter as map. It takes key as a string, value as type double. So basically we'll pass amount in a request body. For that we'll use a map. Okay, next let us call it as request. Perfect. Next, within this deposit method, let us call account service. It has deposit method, and then let's pass ID as a first parameter. Second parameter we need to pass the amount, so we can get that amount from the request object. So here request dot get, and then we can pass key as a amount. Okay, next let us introduce a local variable amount account DTO. Okay, next let us have a return statement, return response entity dot OK, and then pass account DTO in a body. Now we have created a deposit method, and then internally we'll call account service dot deposit method, and then we'll pass ID and then amount. So we can extract this as a separate variable as well. So here what we'll do, we'll store in a local variable, let us say double, and then amount equal to request dot get, and then pass this amount over here. Okay, so this will basically improve the readability. Next, let us annotate this deposit method with @put mapping annotation. Well, we use @put mapping annotation to map incoming HTTP put request to this method. Next, within a double quote slash, and then pass ID. Next, slash deposit. So this is the URL for this REST API. Next, let us store the value of this ID into a method argument using @path variable annotation. So here let us use @path variable annotation to bind value of this template URI variable to this method argument. Next, here let us use one more annotation, that is @request body annotation. Well, this @request body annotation will map the request JSON body into this map Java object. Okay, perfect. Now we have developed the deposit REST API. Next, let us go ahead and let us rerun our Spring Boot application, and let us test this deposit REST API. So here let me stop and rerun the Spring Boot application. Alright, our Spring Boot application is up and running. Next, let us head over to the Postman client over here, and here let's create a new request, and here let us choose HTTP put method, and here let us enter the request URL. So let me copy this and let me paste it over here. Next, let's go to body and then choose raw, and then choose content type JSON, and here let us pass the JSON and the key as amount and the value Let us say we want to deposit 5,000. Okay, that's it. Next, click on send button. So this says method not allowed. Well, here we need to give the correct URL. So let's go to IntelliJ IDEA and let's see the URL that we have given to the REST API. We have given the URL id/deposit. So we need to append this deposit in the URL as well. So here's /1/deposit and then click on send button, and there we go. In a response you can see the JSON account 1, account holder name Ramesh, and the balance is 15,000. Earlier it was 10,000. Now you can see the balance 15,000. Okay, it means we have successfully deposited 5,000 into account Ramesh. Next, let us say we want to deposit 10,000. Next, click on send button and you can see the response, the total balance 25,000. It means the deposit REST API is working as expected. Next, you can see the same change in the database table as well. So go to accounts table, right click, select rows, and you can see the balance 25,000. Okay, it means we have successfully built deposit REST API. Okay, great. Next, let us build withdraw REST API. So let us go to IntelliJ IDEA and let's create the withdraw REST API. So let us first change the service layer and then we'll change the controller layer. So go to account service interface and here let's define the method. Let's give return type as account DTO. Let's give method name as withdraw and let's pass parameter as long ID. Let's also pass the second parameter, that is amount. Perfect. Now we have defined withdraw method in a account service interface. Next, let us provide the implementation for this method in a account service sample class. So let us jump into account service sample class. Just mouse over on this class, click on implement methods, select the method that you want to implement, click on OK. Perfect. Next, let us implement this withdraw method over here. So here, first we'll check whether the account with a given ID is exist in a database or not. If the account with a given ID is not exist in database, then we'll throw the exceptions like account does not exist. Okay, so that piece of code we have already written in a existing methods. So we can copy that piece of code from here. So go to deposit method and copy this piece of code. Okay, and again go to withdraw method and here simply paste it. Okay, perfect. Next, let us add one more condition, like if the withdraw amount is greater than the balance, then we'll throw the exception like insufficient amount. Okay, so here let's add the if condition and then account dot get balance. So if the account balance is less than the withdraw amount, then we'll throw the runtime exception. So here throw new runtime exception and let us pass the message insufficient amount. Perfect. Next, here let us write the logic double total equal to, so here just call account dot get balance minus amount. So in this case we are withdrawing the amount from the balance, that's why we are using a subtraction. Okay, next let's call account dot set balance and then pass total. Okay, perfect. Next, let us call account repository and then call save method and then pass this account object. Next, this save method returns the account saved account object. So let us introduce a local variable of type account. Let's call it as saved account. Perfect. Next, if you can look at the withdraw method over here, it returns the account DTO. So let us convert account entity into account DTO. So here let us remove this null and let's call account mapper and then it has map to account DTO and then pass saved account. Okay, perfect. Now we have implemented withdraw method. Internally it will call account repository dot find by id method. Let us say if the account with a given id is not exist in database, then we will throw the runtime exception. Next we have added one more condition, like if the withdraw amount is greater than the balance, then we'll throw the runtime exception like insufficient amount. Next let us say the balance is greater than the withdraw amount, then we'll write the logic like we'll withdraw some amount from the existing account balance, and then we'll add that total to the account, and then we'll save that account into a database, and then we'll return the updated information. Okay, the logic is pretty simple. Next let us build the withdraw REST API that will internally call this method. So go to account controller. So here let me first write the comment withdraw REST API. So just type public and then response entity, and then pass account DTO. Let's give method name as withdraw, and then pass two parameters. First parameter as id, second parameter as a map. The key type is string, the value type is double, and let's call it as request. Perfect. Next let us get the amount from the request. So here double and then amount equal to request dot get, and then pass amount. Alright, next account DTO equal to account service dot withdraw, and then pass id and then amount. Next let us have a return statement, return response entity dot OK, and then pass account DTO in a body. Perfect. Now we have created withdraw method. It will internally call account service dot withdraw method, and it will pass account ID and the withdraw amount. Okay, next let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add put mapping annotation. Well, this put mapping annotation will map incoming HTTP put request to this method, and then let us pass the ID and then withdraw. Perfect. Next let us bind the value of this ID to this method argument by using at path variable annotation. Next let us use one more annotation, that is at request body annotation. Now we have built withdraw REST API. Next let us rerun our Spring Boot application and let us test this REST API. So from here let us stop and run the Spring Boot application. Alright, our Spring Boot application is up and running. Let's go to Postman client over here, and here let's create a new request. So let me copy the request URL from the existing REST API request. So here let us select HTTP put method and then pass request URL localhost 8080/API/accounts/ the account ID, and then withdraw. Alright, so here we are going to basically withdraw some amount from the account with ID 1. Next let us go to body, select raw, choose content type JSON, and here let us pass the withdraw amount. Let us say I want to withdraw 5,000. Next click on send button, and there we go. In a response you can see the account holder name and the balance. Earlier the balance was 25,000. Now you can see the balance 20,000 because we have withdrawn the amount 5,000. Okay, next let us say I want to withdraw 5,000 more. Then what I can do is I can click on send button, and you can see the response, the balance is 15,000. Next let us say I want to withdraw 10,000, then the balance should be 5,000, right? So let's click on send button, and you can see the balance 5,000. It means the withdraw REST API is working as expected. Next let us build get all accounts REST API. Well, first we'll change the service layer and then we'll change the controller layer, because controller layer is depends on service layer. So let us head over to account service interface over here, and within this interface let us declare a method. So let's give the method return type as list. List is a generic, so let us pass account DTO as a type. Let's give method name as get all accounts. Perfect. Next, let us go and let's implement this method in a account service IMPL class. So let us jump into account service IMPL class over here. Just mouse over on this class, and here you will get a link to implement the methods. Click on this implement methods, select the method that you want to implement and click on OK. Next, let us write the logic to implement get all accounts method over here. So within a get all accounts method, let us call account repository. It has find all method, and notice here find all method returns a list of account. So just call this find all method over here. Next, let us get the result of this find all method in a list. So list and then account, let's call it as accounts. Okay, now we got a list of accounts. Next, let us convert this list of account into list of account DTO. So here let us call accounts. So accounts is a list and list has a stream method. So here just call stream method, and the stream has a map method. So let us use map method to map entity into DTO. And look at here, map method takes function as a functional interface. We need to provide the lambda expression implementation of this function functional interface. So let us call this map method over here, and let us pass the lambda expression implementation. Well, here let us pass account entity object as a parameter to the lambda expression, and then this is the lambda symbol, and then call account mapper. It has map to account DTO method, right? And then pass account entity object. Next, let us call collect collectors dot to list method. Okay, perfect. Well, here we are using account mapper dot map to account DTO method to map account entity object into account DTO. And finally, we are returning the list from the stream, and this list basically contains the list of account DTO. Okay, so here let us have a return statement and remove this return null. Okay, now we have implemented get all accounts method. It will return the list of account DTOs. Next, let us create get all accounts REST API that will internally call this method. So let us head over to account controller over here, and here let me write the comment get all accounts REST API. Perfect. So here let us first create the method, and then we will make that method into REST API. So just type public and then response entity. Response entity is a generic. Let us pass type as a list, and again list is a generic. So let us pass account DTO as a type. Let's give method name as get all accounts. Okay, next within this method let us call account service and then call get all accounts method. So this get all accounts method return list of account DTO. So here let us have list and then account DTO. Let's call it as accounts. Perfect. Next, let us have return statement and then response entity. It has OK method and then pass accounts in a body. Perfect. Now we have created a method called get all accounts. It returns a list of account DTOs. Next, let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add get mapping annotation. Okay, that's it. Next, let us go and let us rerun our Spring Boot application and let us test this get all accounts REST API. So from here, I'm going to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in embedded Tomcat server on port 8080. Next, let us head over to the Postman client over here and let's create a new request and let us choose HTTP get method over here and let us enter the request URL. Well, let us copy from the previous REST API and just paste it over here, and here let us remove these parameters and just keep localhost 8080/API/accounts. Next, go ahead and click on send button and there we go. In a response you can see a list of accounts. So as of now there is only one account. Now what we'll do, we'll add a few more accounts. Okay, so go to the add account JPA over here, and here go to the body and just change the account holder name from Ramesh to John, and then balance, let us have 20,000. Click on send button. Now the John account is created. Next let's create one more account. Let us say Sanjay, and then let's say balance 30,000. Click on send button, and there we go, Sanjay account is created. Next let's go to get all accounts REST API, and next send the request, and there we go. In a response you can see a list of accounts, and there are total 3 accounts in the list. Alright, it means the get all accounts REST API is working as expected. Alright, great. Next let us go ahead and let us build delete account REST API. Well, first we'll change the service layer, and then we'll change the controller layer. So go to account service interface over here, and here let's define the method. So let's give return type of the method as a void, and let's give a method name as delete account, and then pass account ID as a parameter. Now we have defined delete account method in account service interface. Next let us implement this method in account service IMPL class. So let us jump into account service IMPL class over here, and just mouse over this class, click on implement methods, select the method, click on OK. Alright, next let us implement this delete account method over here. Well, first we'll add the condition like if the account is not exist for a given ID, then we will throw the runtime exception. Okay, so that logic we have already written in a withdraw method and deposit method and get account by ID method, right? So let us copy this piece of code from the get account by ID method, and then let's go back to delete account method over here, and within this method let us paste this logic. So here basically we are adding the condition like if the account with a given ID does not exist in database, then we will simply throw the runtime exception like this. Okay, great. If the account with a given ID exists in database, then we will delete that account. So for that let's call the account repository. It has a delete by ID method, and then pass account ID. Alright, perfect. So this delete by ID method returns a void, so we no need to return anything. Now we have implemented delete account method. It will delete an account by given ID. Next let us build the delete account REST API that will internally call this delete account method. So let's go to account controller over here, and here let's write the comment first, delete account REST API. Just type the method public, and then response entity, let us pass string as a type. Let's give method name as delete account, and then pass account ID. Perfect. Next within delete account method let us call account service. It has delete account method, and then pass account ID. So this will basically delete the account by ID. Next let us have a return statement, return response entity dot OK, and then pass the success message here. Let us say account is deleted successfully, something like that. Perfect. Now we have created delete account method. It will delete the account by using account service dot delete account method and return the success message. Next let us make this method as a REST API by using Spring annotations. So here let us annotate this method with @delete mapping annotation. When we use @delete mapping annotation to map incoming HTTP delete request to this particular method. Next let us pass the URI template variable over here. So here braces within a double quote slash within a curly braces ID. So this ID is nothing but a UI template variable, and this ID basically contains the account ID. So we need to bind the value of this ID into the method argument. For that let us use @path variable annotation. Okay, perfect. Now we have implemented delete account REST API. Next, let us rerun our Spring Boot application and let us test this delete account REST API. So from here, I'm going to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running. Next, let us head over to the Postman client and here let's create a new request. Let us choose HTTP delete method over here and here let us enter the request URL. So let me copy this and let me paste it over here, localhost 8080/API/accounts. So let us say we want to delete the account with ID 1. So just pass ID 1 in the URL. Next, click on the send button over here and there we go. You can see the response, account is deleted successfully with HTTP status 200 OK. Next, let us verify in the database. So let's go to MySQL Workbench over here and go to accounts table, select rows and notice here the account with ID 1 is deleted from the accounts table. Next, let us delete the account with ID 2 as well. So let's go to Postman client and here let us pass the account ID 2 in the URL and click on send button and there we go. We got the success message. Next, let's verify in the database. So here let us refresh the table, that is select rows from the table and there we go. The account with ID 2 is successfully deleted. It means the delete account REST API is working as expected. Alright, great.
Hi everyone, welcome back. In this lecture, let us see how to use a Java record class as a DTO class in our banking application. Well, if you look at the banking application code here, we have used a normal class as a DTO class to transfer the data between client and server. Now, we are using Java 17 plus, so we can utilize the latest feature of Java, right? So record class is a special type of class which is introduced in Java 16. So we can use record class to transfer the data between client and server. And the record class basically is a special kind of class that helps you to encapsulate related data without the need for boilerplate code. It means once we create a record class, then Java compiler will automatically generate a getter methods, setter methods, constructors, equals, hash code and toString methods. So in normal Java class, we have to manually create all these boilerplate code, right? But this Java record class tells Java compiler to automatically generate all this boilerplate code. Using record class as a DTO in a Spring Boot application is a modern and efficient approach to encapsulating data transfer between application layers. So basically, record class holds the immutable data and it is a good candidate as a DTO to transfer the data between different layers. Next, records are good fit for DTOs because they are concise, immutable and automatically provide the implementations of getter methods, constructors, equals, hash code and toString methods which are essential for DTOs. So let us go ahead and let us see how to use a record class as a DTO in our banking application. So let's go to our project in IntelliJ IDEA and go to account DTO class over here and here let us go ahead and comment out this code. So here just type public and then record keyword and let us give record name as account DTO and next define the fields long ID and then string account holder name and then double balance. Perfect. So basically these fields are implicitly final. So once we create this account DTO object, we cannot modify it because records are immutable. Alright, perfect. Next, let us go to account mapper class over here and here we have to change these getter methods because record basically provides a getter method name as a field name. For example, here let us remove this get ID method and then call ID. Next, let us remove this and then call account holder name. Next, let us remove this get balance and then call balance. That's it. Now what we have done, we have created a record account DTO and then we have changed in a account mapper. Okay, that's it. Next, let us rerun the Spring Boot application and let us test couple of REST APIs. So from here, I'm going to start the Spring Boot application. So notice here our Spring Boot application is up and running. Next, let's go to the Postman client and let us test couple of REST APIs. So here first let us test create account REST API. So here I'm going to create a new account with a holder name Ramesh. So before that, let us go to the database table over here and let us select the rows from the accounts table. So there is only one account holder, that is Sanjay. Next, let us insert one more account. So here let us give account holder name as Ramesh and the balance 10,000. Click on send button and there we go. The record is successfully created. Let us verify in the database table and you can see here Ramesh record is inserted. Okay, it means the create account REST API is working as expected. Next, let us test get account by ID REST API. So here let us select HTTP get method and here let us pass account ID 6 and then click on send and there we go. We got the response of the REST API. Next, let us test withdraw REST API. Okay, so here let us pass the account ID 6 and then click on send button. So basically look at here the amount 10,000 we want to withdraw and look at here the response. And if you go to database table, the Ramesh user has a balance 10,000 and we have just withdrawn that 10,000 and balance remains 0. Okay, it means withdraw amount REST API is working as expected. Next, let us test the deposit REST API as well. Let us deposit 20,000 to the Ramesh account. So click on send button and there we go, the balance 20,000. And let us verify the database table and look at here Ramesh has a balance 20,000. Next, let us test get all accounts REST API. So here let us remove the ID from the URL, click on send button and there we go, there are 2 accounts in the database table and same we can see in the response of the REST API. Next, let us test the delete account REST API. So here let us pass account ID 3 and click on send button and there we go, account is deleted successfully. It means we have successfully used record class as a DTO class to transfer the data between client and server. Alright, great. Hi everyone, welcome back. In this lecture onwards, we'll start implementing exception handling in a banking application. Let us quickly take a look into how we are going to handle the exceptions in a Spring Boot REST API project. Well, whenever client sends a request, the controller will handle that request and it will send that request to the service. In a service, we basically write the logic to validate the request. Like first we'll check whether the account with a given ID is exist in database or not. If it is not exist, then we throw account exception. Once we throw the account exception, then we have to handle that exception and we need to prepare the error response for that exception and we need to send that error response back to the client, right? So for that, what we'll do, we'll create a global exception handler class. Within that, we will write a logic to handle specific exceptions as well as generic exceptions in a single place. So instead of writing the exception handling logic in each and every controller, we'll create a separate class as a common class and we'll call it as global exception handler. And within this class, we keep all the exception handling related logic. Okay, so this is basically a flow. Whenever client sends a request, the controller will process that request and it will forward that request to the service. Service will validate the request. If there are any issues, then it will throw the exception and then global exception handler will catch that exception. It will prefer the error response and it will send that error response back to the client. So this is the simple flow. Next, let us take a look into few key points about exception handling in a Spring Boot application. Well, handling exceptions in a Spring Boot REST APIs is typically done by using @controller_advice and @exception_handler annotations. Next, @controller_advice annotation enables global exception handling for controllers. So instead of writing the exception handling logic for each and every controller, we will create a separate class and we will annotate that class with @controller_advice annotation. And within that class, we'll write all the exception handling logic for all the controllers. So we'll basically keep all the exception handling logic in a single place. Next, @exception handler annotation defines the methods to handle specific exceptions within a controller or globally with @controller_advice class. So basically we use @exception handler annotation to handle the specific exceptions. So we'll see in a coding section how we can use these two annotations to handle the exceptions in a Spring Boot REST APIs. Alright, in next lecture we will start implementing exception handling in our banking application. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture we had a quick overview about how to handle the exceptions in a Spring Boot application. Well, before handling exceptions in a Spring Boot application, let us understand Spring Boot default exception handling. Well, if you go to our project in IntelliJ IDEA and go to account service sample class, within that go to get account by ID method. So within this method, here we have written a logic like if the account ID is not exist in database, then we throw the runtime exception, right? And if you test this REST API here, well, here I'm going to test get account by ID REST API, and look at here, we got the response. It says internal server error. Well, if you again go to the database first, and here let us select the rows from the accounts table, and here you can see the account ID 3 is not exist in the table, and here in a REST API URL we have passed the account ID 3. Well, the account with the ID 3 is not exist in database, then we got a response like this, but this is the not a correct response, right? So we have to get the error message properly. So here internal server error, so this is not a meaningful error message, right? So this is basically a technical term. And again, look at here the HTTP status 500 internal server error. So the status should be 404 not found, right? Because the account with ID 3 is not found, that's why the status should be 404 not found, but we are getting 500 internal server error. So this is the default Spring Boot exception handling. Now let us go ahead and let us implement exception handling in our banking application as per our requirement. So basically our requirement is like we need to send the status as a 404 in the response, and we need to also send the error message, that is meaningful error message, and we also need to send the error code in the response. Okay, so let us go ahead and let us see how to implement the exception handling in the banking application as per our requirement. So let us head over to the development steps. First step is create a custom exception named account exception. Second step is use account exception. Well, instead of using runtime exception, we will use account exception. Next step is create error details class to hold the error response. Next step is create a global exception handler to handle the specific exceptions as well as generic exception. Alright, so first step is create a custom exception named account exception. Let's go to our project in IntelliJ IDEA and let's first create a new package. So go to base package, right click new and then choose package. Let's give package name as exception, and within an exception package let's create a custom exception. For that choose Java class and let us give class name as account exception. Perfect. Next extend this exception from runtime exception, and within this class let us create a constructor with the name account exception, and then here just pass the message. So this message basically holds the error message, and let us pass this message to the super class constructor by using super method call over here. Perfect. Next let us take a look into next step. Next step is using account exception. Now we have created account exception. Next let us use this account exception in a account service sample class. So go to account service sample class, go to get account by ID method over here, and here instead of runtime exception, so let us use account exception. Okay, perfect. Next go to deposit method over here, and here also we have used runtime exception, so just remove this runtime exception and then use account exception. Similarly go to withdraw method, and here also runtime exception, so just remove it and then use account exception. Next go to delete account method, and here also we have used runtime exception, so instead of this let's use account exception. Okay, now we have removed the generic exception, that is runtime exception, and we have used our custom exception, that is account exception, in a required places. Okay, perfect. Next let us take a look into next step. Next step is create a error details class that holds the error response. So let us go back to our project, go to exception package over here, right click on it, new, and then choose Java class, and here select record. Let's give record name as error details and hit enter. Next let us define the fields for this record. So here just type local date time and let's give field name as timestamp. Well, this is the timestamp when the exception occurred. And next string message, so this field holds the error message. Next, string details. If the user or the client want more information about the exception, then we can store this in a details field. Next, string error code. So we can also send the specific error code about the exception by using this error code field. Okay, perfect. Next, we don't have to create a getter methods or the constructor to string equals hash code, because this is the record. So Java compiler will automatically provide all these boilerplate code. Next, let us take a look into next step. Next step is create a global exception handler to handle the specific exceptions as well as generic exceptions. Well, we will implement this step in the next lecture. Hi everyone, welcome back. In this lecture, we'll implement create global exception handler to handle the specific exceptions as well as generic exceptions. So let us go to our project again, and here go to exceptions package. Within that, right click, new, and then choose Java class. Let's give class name as global exception handler. Hit enter. Next, let us go ahead and let us annotate this class with @controller advice annotation. Well, once we annotate this class with @controller advice annotation, then this class becomes a global exception handler class, and within this class we can define the specific exceptions as well as generic exceptions. So basically, instead of writing the exception handling code for each and every controller, we basically create a single class and we annotate this class with @controller advice annotation, and within this class we keep all the exception handling related code in a single place. Okay, perfect. Next, within this class, let us first handle the specific exceptions. So here let me write the comment handle specific exception. So in this case, account exception. So this account exception is a specific exception that we are going to handle over here. So here just type public and let us give return type as response entity. Response entity is a generic class. We have to pass a type. So in this case, let us pass error details as a type, and let's give method name as handle account exception, and then let us first post parameter to this exception as a account exception. Let me maximize this. Next, let us pass web request as a second parameter to this method. Well, we'll get some request data from this object. Next, within this method, let us create an instance of error details class over here, new error details, and we can pass a data to the constructor. So first value is timestamp. For that, let's call local date time, and then it has now method. So this will basically return the current date time. Next is error message. So we can get the error message from this exception object. So here just call exception dot get message, and then third value, if you go to error details, you can see third value we can pass as a details to the constructor. So let's go back to global exception handler class, and here we can get the details from this web request. So just call web request dot get description. So instead of passing the entire description, we just need to pass the URL. For that, just pass false as a value to this get description method. Next, we need to pass the error code. So here let us give the error code as account underscore not found. Okay, perfect. Now we have created error details class with the proper error response. Next, let us have a return statement, return, and then new response entity, and then pass error details object in the body as a post parameter. Second parameter is the HTTP status. So here just call HTTP status dot not found. Perfect. Now we have created a method. Next, let us annotate this method with @exception handler annotation, and then pass the exception that we are going to handle, that is account exception. Perfect. Now we have written the exception handling logic that handles this specific exception, that is account exception. Let's go ahead and let's write the logic to handle generic exceptions. So here let me write the comment, handle generic exception. Well, if we get any exceptions other from these specific exceptions in our Spring Boot application, that should be handled by using this generic exception. Okay, so here just type public and then response entity and then pass error details as a type. Next give method name as handle generic exception. Alright, next let us pass exception as a first argument and then web request as a second argument. So within this method, let's create an object of error details record class over here and then pass values to the constructor. So first value is timestamp. For that call local datetime dot now method, and then we need to pass error message. So we can get error message from exception object. So here exception dot get message, and then we need to pass the details. So we can get the details from web request object. So web request dot get description method and then pass false as a value to the get description method. Next we need to send the error code as well. For that here just pass the error code internal server error. So if there are any exceptions other than the specific exceptions, we can tell the client that there is some internal server error. Next here let us have return statement, return new response entity, and here just pass error details object in a body and then http status dot internal server error. Okay, perfect. Next let us annotate this method with add exception handler annotation and then pass the generic exception, that is exception dot class. Alright, so if there are any exceptions occurred other than the specific exception, that will be handled by this generic exception logic. Okay, perfect. Next let us go ahead and let us rerun our Spring Boot application and let us test this change. So from here let us stop and rerun the Spring Boot application. Well, our Spring Boot application is up and running. Next let's go to the Postman client over here, and here let us call get account by ID REST API. Well, before that, if you go to database table, and here you can see the account with ID 6 is exist in the database table, and in the Postman client we are calling the get account by ID REST API with the account ID 3. Okay, now go ahead and click on send button, and there we go. In a response you can see the details, timestamp, the message, account does not exist, details, the URL, and the error code account not found, and look at here the HTTP status 404 not found. This response looks good, right? So this is how we can implement the exception handling in a Spring Boot application as per our requirement. Okay, so similarly let us test the positive scenario, that is if the account ID is exist in database, then we should get the correct response. So here click on send button, and there we go, we got the correct response, right? Next let us also test the deposit and withdraw REST API as well. So here click on send button, and look at here the account with ID 6 is exist in database, that's why we are getting the valid response. And if I pass the invalid account ID, that is 3, then this REST API return the error response. Okay, this response looks good. Alright, next let us test the withdraw REST API, and look at here the account with ID 3 is not exist in database, that's why we got the error response like this, and this is the correct error response as per our requirement. Next if I pass the correct account ID in the URL, and if I click on send button, we got the success error response. Next let us also test the delete account REST API. So here let us select HTTP delete method over here and then pass account ID 3 in the URL. Well, the account with ID 3 is not exist in database, we should get the error response, right? So click on send button, and there we go. Next the account ID 6 is exist in database, so this should delete the account from the database, and there we go, this is the success response. It means we have successfully implemented exception handling in our banking Spring Boot application. Alright, great.